So now we're going to look at an example that it's like a typical example that you would see. So here we have three equations, and each equation has three variables in it. So the steps that I have written out, they can be kind of tweaked based off of how you kind of want to solve this. So it's not just like a one and done. There's not just one way to do this. There's multiple ways that you could solve this. So the first thing that I'm going to do is I'm going to label these three equations as 1, 2, and 3. So we've got, this is 1, I'm going to label this one as 2, and this one as 3. All right, so the first step here says to take the first two equations and eliminate a variable. Now, you don't have to use the first two equations. You just have to use two of the equations. So eventually we're going to use all three, and we can only use two at a time. So before we just take the first two, we want to see which would be the easiest variable to eliminate in all three equations. So you could eliminate the x's, the y's, or the z's. So one person might decide to do the x's, another person the y's, another person the z's, and as long as everybody does it correctly, they're all going to get the same answer. I usually look for what variable has the same numbers, so that way, like the coefficients in front, so that way I don't have to multiply by crazy numbers. So I would choose to eliminate the y in all of these because all of the y coefficients are 1. So I'm going to use the first two equations. So I have equation 1, which is going to be x minus y plus z equals -1, and I'm going to use equation 2, which is going to be x plus y plus 3z equals -3. So when you're doing these problems, you want to go nice and slow so you don't make any mistakes when you're writing out the original problems, because these problems can be a little bit tedious and we want to make sure that we're not making any errors as we go along. So we have equation 1 and we have equation 2. So we're going to get rid of the y's here. So the coefficients of the y's are both 1, which is good. They're the same number. And then we want to make sure the signs are opposite. So we can see that the y in equation 1 is negative and the y in equation 2 is positive. So since they're opposite signs, that's fantastic. And we're going to actually just add these straight down. So x plus x is going to give us 2x. The negative y and the positive y are going to cancel out or be eliminated. Z and 3z is going to give us 4z. And then -1 and -3 is going to give us -4. So once I do this, I'm kind of creating a new equation that only has two variables. So what I like to do is I like to circle it because I'm going to come back to it. That's not my answer. I'm not done, but I'm going to come back to this equation. So I'm going to circle that. So step 2 says to take the middle and last equations and eliminate the same variable as 1. Now again, depending on how you're doing this, you don't necessarily have to take the middle and the last. The idea is that you have to use all three equations. So in the first part, we used equation 1 and 2. Okay, we did not use equation 3 yet. So in my next step, I have to use equation 3. I can either use equation 3 with equation 1 or equation 2. So again, I have to eliminate the y, and that's the key here, is you have to eliminate the same exact variable that we eliminated in the first step. So when I look at the y's, I have to use 3, and 3, the y has a negative in front of it, so it's going to be easier to use equation 2 with that because the signs of the y's are opposite. If you want to use equation 1 and 3, you can, but then you have to multiply one of the equations by a negative so that the y coefficients have opposite signs. So let's just always try to take the easy route if possible. So we're going to use equation 2 and equation 3. So we have x plus y plus 3z is equal to -3. And we have equation 3, which is 2x minus y plus 2z equals 0. Okay, so I check the variable that I'm going to try to eliminate, which is the y. They have the same number, coefficient, and they have opposite signs. So that's good. So what we're going to do again is just add this straight down. So x plus 2x is going to give us 3x. Y and -y will be eliminated. 3z and 2z is going to give us 5z. And then -3 plus 0 is going to give us -3. Okay, so again, I'm going to circle this equation. We're going to come back to it. So notice that the two new equations that we have both have x's and z's and no y's. Okay, that's what we want to have. So step 3 says to solve the equations from 1 and 2 for the two variables left. So the two equations that we have circled, this purple one and this black one, we're going to stack those up and do a system using those. So we're going to do a system of 2 with those. So we're going to have 2x plus 4z equals negative 4, and we have 3x plus 5z equals negative 3. Now here I want to eliminate either the x or the z. Okay, so again, it's kind of up to you which one you want to eliminate. The issue here is that neither of them are easy to eliminate because the numbers are different and the signs are different. So I'm going to stick with trying to eliminate the x's. So I need to multiply the 2 by a 3 to get 6 and the 3 by a 2 to get 6 because I can make both the 2x and the 3x into 6x. Okay, again, I do want my signs to be opposite, so I'm going to multiply one of them by a negative and one by a positive. So I'm going to choose to multiply the top equation by a negative 3, and I'm going to multiply the bottom equation by positive 2. Okay, now if you want to multiply the top by a positive 3 and the bottom by a negative 2, you could, okay, as long as one is positive and one is negative. So we're going to multiply this negative 3 to every term on this equation. And a lot of people kind of forget to multiply it to every single piece, and that's a main place where people make mistakes. So we're going to do negative 3 times 2x, so we'll get negative 6x. We're going to do negative 3 times 4z, which is going to give us negative 12z. And then we're going to do negative 3 times negative 4, which is going to give us positive 12. Okay, then we're going to take this 2 and multiply it to every piece of this equation. So 2 times 3x is going to give us 6x. 2 times 5z is going to give us 10z. And then 2 times negative 3 is going to give us negative 6. Okay, so here we've made the coefficients of the x's the same number and opposite signs. So now we're going to go ahead and add this straight down. So negative 6x and positive 6x, that gets eliminated. Negative 12z plus 10z is going to give us negative 2z. And then 12 minus 6 is going to give us 6. I can divide by negative 2. And I'm going to get that z, that's an arrow there, z is equal to negative 3. Okay, so once I get that z is equal to negative 3, I'm going to plug that into one of these two equations. So the equation that I had circled, I'm going to plug that z into one of those because I don't want to plug it into one of the originals because I don't have all the variables. So I'm going to plug it into either of these two, does not matter which one. I'm going to just choose the first one. So I'm going to do 2x plus 4z, but z is now negative 3, and that's equal to negative 4. So this becomes 2x minus 12 equals negative 4. We're going to add 12, and we'll get 2x is equal to 8. And then when I divide by 2, we're going to get that x is equal to 4. Okay, so now we have z and we have x. In order to find y, we're going to go back to our original 3 equations. Okay, so it does not matter which of these 3 we use, but we're going to use one of the 3. I always go for the easier one, so I'm going to do number 1. So I'm going to use number 1 again, which was x minus y plus z equals negative 1. So x we now know is 4, y we don't know, z is going to be negative 3, so plus negative 3 equals negative 1. So if I combine like terms, 4 and a negative 3 is going to give us 1. So 1 minus y equals negative 1. To get y alone, I'm going to subtract 1. So negative y equals negative 2. And then I'm going to divide by negative 1. So y is equal to positive 2. So again, we want to write our answer as an ordered triple. So we're going to go in alphabetical order. So we've got x, which is 4, y, which is 2, and z, which is negative 3. Okay, so I kind of like to think of this problem as like a ladder. So you start at the top of the ladder, and then you work your way down the ladder, and you get these 2 new equations, and you keep going down the ladder until you solve for one of the variables, and then you start going back up the ladder. So once you've found one of the variables, you go to the previous step, which is where we found the two equations, these two equations, and you plug it in to find the other one, and then you go back to the top of the ladder and use that original equation.